Hi everyone, and welcome back to another AP Calculus video. Today we're going to talk about slope fields and what the heck they are and how you can generate them. Essentially, let's recall that when we solve a differential equation like the one shown here, it has an infinite number of solutions. We can find the particular solution, which is a specific solution, if we have a little bit of information about a point that the original function passes through. This is called the initial condition. But assuming that we don't have the initial condition, when we solve these problems, we often have to add our constant. Well, we always have to add our constant of integration. That's the plus c that we tack on every time. And if we think about the solution for this particular equation, all we'd have to do is find the antiderivative. So we're going to kind of explore this real quick on a graph. And Desmos has a great slope field generator, and we're actually going to use that here in just a minute to check some of our answers. But suppose we have this equation, so this is the given equation, and this would be its antiderivative. So this red graph here, this is the solution to this differential equation. And we have this c value, and depending on what c is, that solution is going to float up and down the y-axis. Now, for a polynomial, that's how it goes. It would just go up or down. But other functions might have different behaviors. We've seen before when we solved a function involving the absolute value of y, and we did the natural log, and we had e to the power of something, that sometimes that constant ends up being a multiplied coefficient of e to some power. So it really depends on the behavior of the function, whether c will just make it go up or down. So you can see that here's all, this is where my function could lie. Really, there's kind of an infinite amount of space. Now this only takes me from -10 to 10. So if I wanted to show all the possible solutions from where c is 10 to -10, just to kind of limit things and keep it from being insane, here's a graph of all the possible solutions. Now these are the integers, so these are just some of them here passing through 1, 2, 3. So this is when c is 1, when c is 2, when c is 3. It doesn't include any of the spaces in between. So looking at my red line, it really could float anywhere between. But what this does is it gives me an idea where if I didn't know the solution, but I knew a little bit about what was happening, I could create a field of slopes, because each of these little hashed lines represent the slope or the derivative of the original function. So remember, the derivative of a function is all about the slope of the curve at a point. And so if I were to sketch little itty bitty tangent lines, they might look like these little dashed lines here in blue. And that's what a slope field is. And essentially what you see here, this is a slope field for this function, because it gives us a picture of all the possibilities. And we can see that the function must go up, flatten out a little bit, and then continue up based on these little hash marks, which if we went and sketched the tangents at those little spots, it would be these hash marks. Those are the derivatives, right? So if we were to make a picture of the derivatives, we would get what we call now a slope field. And this is essentially a slope field because it gives us an idea of the slopes of the curve, or the derivatives of the curve. Now, if we want to sketch our own slope field, let's talk about how we're going to do that. So here is an example of something we can start with. So I have an equation, a differential equation, that I cannot solve. So the key here to slope fields is that usually we can't solve them. If we could solve this, then we'd get our solution and we wouldn't need a slope field. But this we can't solve. We can't separate variables. We can't put y on the other side using subtraction. That's a big no-no. You can only use multiplication or division when trying to solve that method. So here there is no solution that we can find easily. So what we do is we create a slope field, right? And so we say, okay, I'm going to start at one spot. I'm going to start here at 0, 0. And basically, I'm going to say, well, at 0, 0, the slope, and actually there's a better way to write this. Let's do this the proper way. At 0, 0, the slope would just be x plus y. Well, I know x and y are 0 and 0 because that's kind of how this works, right? So dy dx at 0, 0 is 0 plus 0, or 0. So right here, what I'm going to do is I'm going to draw a little tick line with a slope of 0. It's a picture of the slopes. So right there, slope of 0, horizontal little line. So then I'm going to pick a couple more, and I'm going to basically I'm going to go out to like 1, I'm going to go out to 2. So I'm going to go right here at 1, 0, and I'm going to find the slope there, dy dx at 1, 0, x is 1, y is 0, is going to be 1 plus 0, or just 1. So what I'm going to do is I'm going to try my best to create a little slope that looks like 1. Now as I go, I don't need to write every little thing down. There's a lot of times when I'll be doing this and I'll say, okay, well I'm just adding the x and the y coordinate. So right here at 2, 0, 2 plus 0 is 2. Now my slope is 2. I want to make sure that whatever slope I put there is a little steeper than a slope of 1. And I'm going to do that for a couple more points. And, you know, just to keep it sane, we'll kind of, maybe we'll just do the first, I don't know, we'll do these 18 points here, something like that. So then I'm going to go up here to 1, 1. At 1, 1, I'm going to add them together, and I get a slope of 2. Okay. Here at 0, 1, I get another slope of 1. Okay. But here at -1, 0, I have a slope of -1. So I'm going to make sure that I put a slope of -1 here. My slope needs to go the other way. Here at -1, 1, I'm going to get a slope of 0. When I add the two coordinates together, I get a 0 slope. Same thing's going to happen down here at, well, actually, no, it's not going to happen down. Oh, yes, it is. -1, 1. Okay. I shouldn't second guess myself. And then over here, -1, -1, this is a slope of -2. So I need to make sure that I show that it's a steeper slope. And I can do this all day long. I can make a slope field as big as, you know, as big as a house. So let's do a couple more here. We got 2, 1, that's going to be a slope of 3. So they just get steeper, right? The further up I go, they're getting steeper. Okay. So, and then over here in negative territory, I just have to be careful because some of these are positive. So -1 and 2 make a positive 1, so I have to show a positive slope there. But then somewhere over here, like 2, this is going to be a positive slope also. But then at some point, I'm going to get another 0 slope. So I'm going to have this line of 0 slopes where x and y cancel each other out because they're adding together to create 0. And I could go all day long here and, you know, make these points. And what usually happens on a test or an AP exam is that the directions will say, you know, just do these dots, and they'll give you like 9 dots. Okay, so it won't be overwhelming. This is a lot of dots for a slope field, but we're learning, right? And it's super duper easy. You just take the equation, plug the x and the y coordinates in, and then make a little, try to guesstimate where the slope is. And they won't be, you know, sometimes on your homework and in class as we practice, we get some weird slopes like 25/4. That's a weird slope. On the AP exam and on a test, it'll be pretty concrete. It'll be whole numbers, integers, things like that. And your goal is to just, if your slope is 4, make it steeper than a slope of 1. Make it appear steeper, and you'll probably get full credit for that. Now, there's a slope field generator here, and actually, if you just Google it, that's what I do every time. I go and I Google my slope field generator on Desmos, and here's what I get. And if I plug in our equation x plus y, here's what it looks like. You'll notice we've got these lines of, you know, all I did was type the equation in right here. You get these little lines of, here are your 0 slopes where the x and the y cancel each other out. Oh, and then you have the slope of -1s. Huh, that's interesting. So if we look and see, compare what Desmos gives us to what we were having, there we go. So it looks like we're lining right up. So we had these slopes of +1 to the right of those 0 slopes. And then all along in here, this is where we were going to have these slopes. So my slope field generator matches what I was sketching, and that's a good thing. Now, you should not use the slope field generator to do your homework for you. You should use it to check your work as you go. So if you want to find that, all I did was Google Desmos slope field generator, and that's a good way to check. So let's try a few matching problems. This is really how the AP exam presents slope fields. With some matching. So if I wanted to match each differential equation with its solution. What I'm going to look for are zero slopes, undefined slopes, and also slopes where, you know, it's going to be exactly 1 or negative 1, where things are going to cancel out. So that's what I'm going to look for first, is zero slopes. So those are my little horizontal tick marks. Vertical tick marks, those are undefined slopes, and then slopes of 1. So if I'm looking at my equations, this dy dx is x over y. We've got x times y, x minus y, and y over x. This is going to have an undefined slope wherever y equals 0. It's going to be undefined. And what that means is I should have a vertical line. So I'm going to look at my graph and I'm going to see, okay, where y is 0 is right along the x-axis. So if I'm looking at these, I'm going to look for vertical lines, along the y-axis. And look right here, vertical lines right along the y-axis. So I'm going to go out on a limb, and if I label these, we'll go ahead and call these A, B, C, and D. I'm going to label this one C, because it's undefined where y is 0. I'm also going to go down here to this other one, and this one will be undefined when x is 0. That's where I'm going to have vertical lines. So where is x equal to 0? Well, that's anywhere along the y-axis. So looking right here, there's all these little vertical lines, so I'm going to match this one up with A. So the key here is looking to see where do we have vertical lines or horizontal lines. Now, B and D, I've got to figure out which one goes to which. So I'm going to use this right here, and x and y, when they subtract, they equal 0. When x equals y, this slope is going to be 0. So all along the line y equals x, I should have 0 slopes. So if I look and see, is there an example where I have 0 slopes? Let's see. C had 0 slopes. Let's see, maybe, just maybe. So as I'm looking a little closer at these, it appears that this equation here also may end up going with C. So let's go back one more time and look at the one we originally thought was for C. So let's see. Where x equals y, we're going to have a slope of 0. Oh, and you know what? I chose the wrong. It's not C that I'm looking at. Yeah, it is. Sorry. Second guessing myself again. So perhaps this one goes with C. So we're going to go back and we're going to re-examine this equation. So we were right to be looking for where y is 0, but what was throwing us off, or what was throwing me off, is that C appeared to be the only graph with vertical lines at that x-axis. When in fact, just because of the conditions here that Desmos has, if I look at what's happening here in graph B, these slopes are also approaching a vertical line. So even though they're not graphed, they're approaching vertical at that spot, which leads me to believe that perhaps B is the way to go here. Now, to be sure and to kind of confirm, we should also note that when y equals x, we get a slope of 1. So all along this line y equals x, you can see that all the slopes are equal to 1. So that's another way to confirm that B is in fact the one that goes here. So sometimes it's not enough just to look for those vertical lines. Along the line y equals x, when y equals x, our slopes were 0. So it didn't line up with that equation. So even though the undefined part lined up, the rest of it did not. So let's take a look. This one then by process of elimination would go with D. Let's just verify that that's the case. So here there would be no undefined values. And when x and y, let's see, you would have slopes of 0 when x equals 0 or when y equals 0. So all along the x-axis, all along the y-axis, we have slopes of 0. So I feel good. This makes me feel confident about this. Now, one other skill that you're asked to do on the AP exam with regard to these types of problems is to sketch a curve through a particular solution. So what I kind of want to do is I want to back up a little bit here and kind of examine each of these so that you can get a feel for what it's telling us, right? So what we're seeing here is this is an image of what this function, or what the particular solution might look like. And I think A is a little tougher to hash through. So let's let's take a look at this problem down here. This one is actually really easy to see. And if you were going to sketch this function and the solution, it really looks like this might be an asymptote, and you would have kind of like this action going. You'd have like a function like that, and then you'd have another piece coming up kind of like that and approaching that asymptote in that way. So you have this slanted asymptote. This would be kind of how I would draw the curve. Now, if you wanted to draw the particular solution through the point, I don't know, -1, 0, you would simply put a dot at -1, 0, and then kind of follow the pattern, you know, just do your best. Not perfect. And then I don't know where the rest of this would go. I mean, I don't know that this would be a good problem to do this type of a question with because of that asymptote and not really knowing necessarily where the other branch would be. But like this function right here could be a really great function for trying to figure out. It almost looks as though this function kind of follows, well, yeah, it follows kind of like this path right here. So you could very easily plot that point and kind of sketch the graph through there. Now, I don't know, it might actually go kind of like this. This might be an asymptote. So it could go either way. But essentially, the ones that the AP exam will ask you to draw pictures through, yeah, the more I look at this, the more I'm convinced that this is more what it looks like. The more that you, if you're asked to draw a particular solution through a point, really you just plot that point and sketch the best curve you can following the flow of your slope field. So this is how slope fields work, and the whole goal of a slope field is to give you a picture of the solution, give you an idea of how it behaves when you cannot find it algebraically. They do show up on the AP exam quite regularly, and remember, matching is a really common way that they'll ask you about it. So make sure that when you're matching, you're looking for as many criteria as you can. Start with those zero slopes, start with undefined slopes, and then go on from there, find one other place, look for where the slope might be 1, and use that to match it up. Because we saw here as an example that just using the one criteria matched us with more than one graph. So we want to be careful and use as many criteria as we can to rule out answers that aren't actually the answer. So keep at it. Slope fields are not a difficult task, but again, it's something that's easy to mess up on. Usually they're worth 2 points, 1 point for any undefined or zero slopes, and 1 point for any other slope. So you're going to want to practice it and, you know, keep at it and make sure that you don't get rusty or forget how to do these. And yeah, just keep practicing. You can do it. You've got it.